Welcome everyone. Today, we'll explore testing methods and standards that ensure material quality and reliability. We'll cover density and thermal testing, electrical and magnetic properties, and corrosion resistance testing. These methods are essential for engineering applications where performance and safety are critical. Testing methods and standards are the backbone of quality assurance. In this session, we'll discuss why they matter, what global standards exist, and how they guide material evaluation. Our agenda includes density and thermal testing, electrical and magnetic properties, corrosion resistance, and the role of standardized methods. Testing methods and standards are critical in ensuring the quality, reliability, and safety of materials and components used in engineering and manufacturing. These methods provide a systematic approach to evaluating physical, thermal, electrical, magnetic, and chemical properties, which are essential for predicting performance under various conditions. Standards such as ASTM and ISO establish globally recognized protocols that guarantee consistency and reproducibility of results. By adhering to these standards, engineers can make informed decisions, reduce risks, and comply with regulatory requirements. This introduction sets the stage for understanding why rigorous testing and standardized procedures are indispensable in modern industry. This presentation will cover four major areas. Number 1, density and thermal testing, including Archimedes' principle, pyknometry, DSC, and dilatometry. Number 2, electrical and magnetic properties, focusing on 4-point probe techniques and pH loop analysis. Number 3, corrosion resistance testing, highlighting ASTM G series, salt spray tests, ASTM B117, and electrochemical methods, and, number 4, standards for reliability, emphasizing the role of standardized methods in ensuring reproducibility and comparability. Each section will include diagrams, practical examples, and detailed speaker notes to facilitate understanding and application in real-world scenarios. Density and thermal properties are fundamental for material selection. They influence strength, weight, and thermal stability, which are critical in aerospace, automotive, and construction. Density and specific gravity are fundamental properties that influence material selection and performance. Archimedes' principle is commonly used for irregular solids, where the buoyant force in a fluid determines the volume and thus the density. Pyknometry, on the other hand, is a precise method for powders and liquids, using a calibrated pyknometer to measure volume displacement. These techniques ensure accurate determination of material density, which is crucial for applications in aerospace, automotive, and construction industries. Understanding these methods helps engineers predict material behavior under load and optimize designs for weight-sensitive applications. Thermal analysis is essential for understanding how materials respond to temperature changes. Differential scanning calorimetry, DSC, measures heat flow associated with phase transitions, providing insights into melting points, crystallization, and thermal stability. Dilatometry evaluates dimensional changes as a function of temperature, which is critical for materials exposed to thermal cycling. These tests help engineers select materials that maintain structural integrity under thermal stress, ensuring reliability in applications such as electronics, automotive engines, and aerospace components. Next, we'll look at electrical resistivity and magnetic behavior, key factors in designing efficient electronic and electromagnetic systems. Electrical resistivity is a key parameter for materials used in electronic and power systems. The 4-point probe technique is widely employed because it minimizes contact resistance errors, providing accurate measurements of resistivity across a sample. This method involves applying current through 2 outer probes and measuring voltage across 2 inner probes. Accurate resistivity data ensures proper material selection for conductors, semiconductors, and insulators, impacting performance and energy efficiency in electrical applications. Magnetic properties are evaluated using pH loop analysis, which characterizes the relationship between magnetic flux density, B, and magnetic field strength, H. This analysis reveals critical parameters such as coercivity, remanence, and saturation magnetization, which are essential for designing magnetic components like transformers, motors, and sensors. Understanding these properties helps engineers optimize performance, reduce energy losses, and ensure reliability in electromagnetic systems. Corrosion can compromise safety and durability. We'll examine ASTM-G series and salt spray tests, along with electrochemical methods for deeper insights. Corrosion resistance is a critical factor for materials exposed to harsh environments. ASTM-G series tests provide standardized procedures for evaluating corrosion behavior under controlled conditions. Salt spray testing, ASTM B117, simulates marine environments by exposing samples to a saline mist, assessing their ability to withstand chloride-induced corrosion. These tests are widely used in automotive, aerospace, and marine industries to ensure long-term durability and safety. Electrochemical techniques, such as potentiodynamic polarization and electrochemical impedance spectroscopy, provide detailed insights into corrosion mechanisms and rates. These methods allow engineers to predict material performance in specific environments, optimize protective coatings, and develop corrosion-resistant alloys. By understanding electrochemical behavior, industries can reduce maintenance costs and extend the service life of critical components. Standardized methods ensure reproducibility and comparability across labs, supporting compliance and global trade. Standardized testing methods, such as those defined by ASTM and ISO, ensure reproducibility and comparability of results across laboratories and industries. These standards provide clear guidelines for sample preparation, test execution, and data interpretation, reducing variability and enhancing confidence in material performance data. Compliance with standards is essential for regulatory approval, quality assurance, and global trade, making them a cornerstone of reliable engineering practices. Let's recap the key takeaways from today's session. Testing methods and standards are vital for ensuring material reliability and performance. Density and thermal testing provide insights into structural and thermal stability, while electrical and magnetic property assessments guide the design of electronic and electromagnetic systems. Corrosion resistance testing safeguards against environmental degradation, and adherence to standardized methods guarantees consistency and trustworthiness of results. Together, these practices enable engineers to make informed decisions, enhance product quality, and meet stringent industry requirements.